Good afternoon, everybody. My name is Mark Massias. I'm a sales engineer, and I'm joined by Edward Ledbeduke, who's a senior cloud engineer working in our global cloud team. And for the next 30 minutes or so, we're going to be covering this really interesting topic, which is HealthShare, Health Connect Cloud. Now, I'm obviously a bit blinded over here, but I can probably see hands. So can I have a quick show of hands for how many of you are actually using Health Connect? Okay. How many of you know what Health Connect is? Excellent. So I'm glad to see the InterSystems people are putting their hands up, which testament to the fact that Mike is doing a good job in marketing. So let's go into an agenda for what we're going to be covering in this short session. We'll start off by giving you an overview of Health Connect Cloud. What is it? How does it work? And so on. Then we'll give you a live demo of Health Connect Cloud, which takes the form of creating a Health Connect instance, and you can see a production, so on and so forth. And hopefully through that, you'll see how easy it is to deliver integration with Health Connect Cloud. And then we'll go on to a case study. Now, this is really, really exciting. This is our first global customer that's gone live with Health Connect Cloud, which is the Northwest London ICS, or the Integrated Care System. Now, for any of you working in the NHS, you'll be familiar with ICSs. They are organizations which were set up in July this year in order to join up health and social care. And in essence, it's a variety of different organizations under a particular ICS. So we'll be looking at that as a case study. So what is Health Connect Cloud? Health Connect Cloud is, as was described earlier today by Jeff, it's platform as a service, which is managed by InterSystems. At the core of that proposition is the Health Connect product, which is an integration engine, which is very prevalent in the world of healthcare. Certainly in the UK and Ireland, it's very, very widespread, and it supports high transaction throughputs. And as you'd expect, it's delivered on the cloud. So let's look at a bit more detail about this. At the core of the Health Connect Cloud is a data platform, which is the Iris data platform, and by virtue of that, there's huge amounts of scalability. Meaning two-directional scalability, which is to say that we can serve small hospitals, of which we have many using on-prem Health Connect, but we can also extend this through to an integrated care system or a whole region, for example. And the final point is that this service, Health Connect Cloud, is delivered at the moment on Amazon, so AWS, in a number of different regions, but the intention is to extend this to a larger number of regions, and also to have deployments or instances of Health Connect Cloud in the main cloud vendors, meaning Azure, with which we've made a lot of progress, and also other cloud vendors such as Google. So with that overview, I'd like to pass you on to Edward, who's going to go into a bit more detail about the architecture of Health Connect Cloud, and also lead that in with a demo as well.
Thank you. Okay, and if it's your first AWS diagram, don't panic. We'll go through it, and it would be really, really easy. And as Jeff said on a cloud session today, our goal is to be able to combine various cloud offerings as a sort of a Lego. But inside each individual offering, such as Health Connect Cloud, there is also a lot of functionality and customization available for you through our cloud portal. There are different ways you can deploy Health Connect Cloud. We recommend you have several environments, one for dev, one for test, and live at a very minimum. And for example, you can have dev only in one non-highly available instance, but for test and for dev and for prod, for live, you can have high availability and mirroring, which you can see on this diagram. Mirrors go into different availability zones, and Arbiter goes into yet another availability zone. Web Gateway and the instance itself are separated and are available in different subnets, and that's the basics. In addition to that, you can have a message bank And you can have, if you want to connect to the instances privately, either a VPN connection or a direct connection if you have your workloads outside of AWS. If you have your workloads in AWS, we can do a connection between VPCs. This way, no traffic leaves AWS network at all. In addition to that, you can have a file share to upload, download files to use with our file-based business services and business operations. Some other parts of this slide is monitoring, which is immediately available in all configurations. So if something goes wrong or something goes outside of expected values, everyone is immediately notified about that. So what does Health Connect Cloud brings you in addition to Health Connect? Health Connect Cloud is basically a managed Health Connect. And what we do is, first of all, we take care of the provisioning. We provision the infrastructure, we get Iris there, sorry, Health Connect, I mean, of course. After that, it's continuous monitoring of running Health Connect instance or running Health Connect mirror with adjustment of storage sizes if it's necessary, of regular backups, and so on and so forth. And it's all reported. If something goes wrong, if you experience an abnormal condition, we are immediately notified. High availability of automatic mirror configuration. You add a new namespace and it's immediately mirrored, available on primary and on backup. Data security, we have database encryption, configuration management with CI/CD. I will talk about it on a later slide. And of course, you have support, SLA, and incident management. CI/CD is I think, is one of the most important parts which we offer. So the development is done using Visual Studio Code, stored in Git repository, and CI/CD is done using GitLab. It allows you to easily promote code between all environments while keeping code consistency. You can mix and match automatic and semi-automatic approaches. For example, you can have this flow, which we recommend, but it definitely can be adjusted based on your needs. First, you commit to, and this code is immediately deployed to your dev instance, and basic tests are run. If they pass, the code is automatically pushed into a test environment, and a more extensive test suite is also run. After that, we stop, we take a pause, and this code is ready for promotion to live, but it's not promoted to live automatically. In CI/CD configuration, you have a button, and it's enough for you to just press this button and the code goes to live. So that part is also automatic, but the trigger event is manual. That's one of the examples. CI/CD is also a building block you can combine. What exactly do you want? In any way you want to achieve that. We just provide a basic configuration which already works with several of our customers, but you can definitely adjust it to your specification. Same as promotion, regression or rollback to a previous state is also easy. In fact, you see a list of all past deployments to any of your environments. And if you think you need to roll back, it's as easy as pushing a button. So you have this one single point of troubleshooting, monitoring, auditing, and also it allows you to separate access. Developers must have access to dev instance, probably have access to test instance, but you likely don't want them to get access to live instance, because there you have patient data flowing, and that's also available. And well, with these three tools, we give you a consistent process of code development and code delivery. Updates are also automated. So we automatically update operating systems, software packages, which are parts of operating system, and InterSystems Health Connect too. So everything is kept up to date automatically during service windows. Critical security vulnerabilities are addressed in 24 hours. And everything you deploy in our cloud portal is monitored, and everyone is notified if there is an emergency. For networking, as I said, you have several options. First of all, you can have a VPC connection. The fastest and probably the easiest way to connect to AWS resources privately and securely. If you have a large volume of data you want to shuffle between your on-premise environment and cloud, it would be a direct connect attachment. And you can also have a VPC attachment in case you have other workload which is already running in AWS.
Something which is really exciting, which is our first customer, which happens to be in the UK, happens to be in London, so absolutely great. And this is the Northwest London Integrated Care System. So who are these folks? These folks cover this section of London, so from Westminster through to Hillingdon. It covers a population of 2.1 million citizens. And as I said before, these ICSs are NHS entities that were formed in July this year in order to amalgamate health and social care. So these boxes over here, which I don't expect you to be able to read at the back, are essentially a series of acute hospital trusts, mental health, community, primary care, social care, ambulance, and so on. So within that patch, there's 4 acute trusts. There's Chelsea and Westminster, there's Hillingdon, there's London Northwest University, and there's also Imperial. And all of these are typical large trusts that have existing trust integration engines. All of these are running Health Connect on-premise at the moment, or mainly at the moment, other than Imperial College. Imperial College is running with an integration engine called Oracle SOA, which is one of the few sites that I know of in English NHS using Oracle SOA within healthcare. I'd also like to make a mention of our partner, Optimus. So Optimus are a partner based out of London, providing services across the globe, really. And this partner deals with 3 of these trusts and has been very pivotal in taking their on-prem integration and moving it through to the cloud, which is Health Connect Cloud, but also reworking the Oracle SOA, which is obviously a completely different technology stack, and rewriting that into Health Connect. So that's Optimus. So let's talk a little bit about the drivers for change. Why did these 4 trusts decide to move towards Health Connect Cloud? Why did Imperial decide to move away from Oracle SOA towards Health Connect on the cloud? And the reason, there's a number of reasons. One of the reasons is that all of these trusts are moving towards a single Cerner EPR instance. And given the fact they're going to have a single instance, you can imagine a lot of the integration between Cerner and shared downstream systems is going to be common across all the different trusts. So the idea of having an integration engine which serves all these 4 different trusts and enables collaboration and of interface development is very appealing. Another point is that these trusts have a lot of skill in developing interfaces. They have development teams that do this. But when it comes to managing the environment, so managing the operating system, managing the whole Health Connect software, managing the interfaces and so on, that's something that trusts typically struggle with. So being able to offload that to InterSystems to do that, as Edward explained, is very beneficial. These trusts were developing interfaces with a variety of different development techniques. Some using VS Code, some using Studio, some using different flavors of source control. So then moving towards a single version of development methodology made a lot of sense. And that's what we've been able to give them. And the final point is that in the NHS, there is a directive to move towards the cloud or to move off-prem. And obviously, Health Connect Cloud does exactly that, supports that initiative. So let's look at the architecture in a bit more detail. It's first of all running in the West 2 region, which is an Amazon Web Services region, which is also referred to as the London region. And it's hosted on 2 different availability zones. So for those of you that are not familiar with AWS speak, these availability zones or AZs are typically 1 or more data centers. So each of these AZs is not 1 data center. It could be 1 or perhaps 2 or 3 of them. And the idea behind hosting this in different availability zones is to deliver high availability within the region and also disaster recovery within the region as well. The products that were implemented to start off with were Health Connect, a message bank, which I'll describe in a bit more detail in a few minutes. It's a specialized Health Connect production. There's also Spine mini services, which some of the trusts already had, which gives them access through to NHS-based services on Spine. So things like NHS number, demographics, GP details, and then subsequently things like child protection information sharing as well. Fire repository is an option as part of the solution, which hasn't been taken on board by Northwest London ICS, but that's something that if they wanted in the future could easily be switched on. And as you would expect, HSCN connectivity is part of the solution for certainly for England, and VPN connectivity as well in order to be able to encrypt traffic between on-prem solutions, the Health Connect Cloud on AWS, and also other data center-based solutions, such as, in this case over here, Cerner. So a bit more detail about the deployment architecture. There's mirroring being implemented for live and also for test. The reason being is so you can actually test the mirror failover, so you can ensure your code works when you fail over the mirror from one member to another. And then there's a single deployment development instance. And as I said before, these mirror instances run in different availability zones, or AZs as they're also known. This is one set of instances which serves all these 4 trusts. So we don't have 4 different instances of Health Connect. We have one instance that delivers for Chelsea and Westminster, Imperial, London, Northwest, and Hillingdon. And what that does is then allows them to share code. So they can have their own private integration code within their namespace, but also be able to develop code and put it into a shared database, which is mapped through to a namespace called %or, which is a virtual namespace that automatically makes that code available in other namespaces. So the idea is if I'm a developer within Imperial, I can build an interface, put it into this shared database, and automatically that interface becomes available to the other trusts in their own namespaces through this concept of a mapping. Separation and concern is key to this, because essentially we have a solution that's delivering a capability to 4 different trusts, and in due course it'll probably be more than 4 different trusts. So security is implemented so that if I'm a Chel West developer, I can look at my own production, perhaps my own dummy data in test and development, but I won't be able to look at Hillingdon's, for example. So all that is implemented through security. As we said already, HSCN is part of the solution, and also the ability to deliver VPN within HSCN as well is part of what London Northwest are also doing. The message bank is a specialized Health Connect production. And the purpose of the message bank, or the raison d'etre message bank, is to be able to store messages in an environment for longer than it's held within Health Connect. Such that I can then search that message bank and be able to replay messages if I need to do that. So it becomes like an audit trail of sorts, but more than that, in the sense that it gives you ability to look at messages that might have failed a while ago and be able to replay those against the the downstream systems. So in the case of London Northwest, we're storing messages in Health Connect for a month, and then messages are being stored in the message bank for a year. In terms of configuration management and source control, meaning CI/CD, there's GitLab being used in combination with VS Code as the development environment. What I'd like to say is that these things over here are options, as you will have seen Edward when he set up a Health Connect Cloud instance, which is to say that some customers won't want to use the message bank. Some customers might not want to store 30 days worth of messages in Health Connect. They might only want to store 7 days worth of messages, and Health Connect Cloud can do exactly that. So this is not a cookie cutter type system. This can be configured according to the requirements of individual trusts. So if you've worked in integration within the NHS, you will know that much of the integration within an acute hospital trust, it boils down to HL7 version 2 messages flying around through TCP/IP. That's kind of the core of what a trust integration engine does. But then obviously you've got the other 20% of integration that you need to be able to deal with. So things like handling on-prem files. So the context of this is many trusts store PDF and text files that ultimately get input into an integration engine, into Health Connect, in order to generate a discharge summary, or in order to generate a clinic note that then is sent down to GP practice. So we had to implement a solution that allowed that kind of capability, that kind of functionality. So there's a third-party solution called Wasabi, which is an AWS native solution that allows you to synchronize files on-prem onto the AWS cloud in different types of formats on AWS as well. This is a solution that already been trialed by Imperial College, so it was tried and tested, and this became part of the Health Connect Cloud solution for Northwest London. The other point in that kind of context is having read in those PDFs and those text files to generate discharge summaries and clinic letters. If you want to send it down to GP practice, there's a mechanism by which you can do that, which is called Mesh, which is something that's supported by the NHS. So some of the trusts had implemented a solution using the Mesh client, which is a flat client solution, but we have an implementation of the Mesh API, which is certified by the NHS. So we're helping those trusts to move code away from using the Mesh client to using Mesh API. Another aspect of what was required in order to make this work is being able to access on-prem databases. So some of the integrations within these trusts relied on doing calls against on-prem SQL Server and MySQL database in order to grab some more data, augment that data within the message, and then send it down the line. So what we did is we implemented an ODBC link between Health Connect Cloud and on-prem. So the Health Connect Cloud could actually fire that query against on-prem databases to support the type of integration which is currently present in these trusts. And the final point is, as we move on, I'm sure there will be some new requirements, and I think it's important to understand that this service is easy to modify, it's easy to augment, so in order to support new requirements. So progress so far. So the solution went live a couple of weeks ago with 3 interfaces out of the Hillingdon Hospital. So far, so good. And the intention is that we're going to migrate, we're going to make those other interfaces, which are on-prem, live over a period of time by phasing them across trusts and interfaces. The Oracle SOA interfaces will have to be rewritten, and that's something that our partner Optimus are in the process of doing. And most of the Health Connect interfaces, which exist within Chelsea and Westminster, London, Northwest, and Hillingdon, have moved over and been tested to a large extent. And the trusts are that the integrated care service is looking towards a migration by Q1 of 2023, which is pretty good. So, summary of the benefits that Health Connect Cloud provides Northwest London. It's a solution which is fully managed by InterSystems. So there's no need to worry about setting up mirroring, ensuring the mirroring is working properly. No need to worry about upgrades and patches. Obviously, there's a level of interfacing that we have with a customer in order to upgrade the software, because obviously there's some testing that needs to be done, but to a large extent, that's done by InterSystems. Another point which I think is important to understand is that this is not solely an integration solution for these 4 trusts. This is a solution for the whole of the integrated care system. So all those boxes that you saw in the slide I showed, all these community, mental health trusts and so on, have access to this solution. So if they want to spin up, or they want to set up rather, a production to deal with mental health integration, they can do that at no further software cost, which is to say that the software is free. Obviously, it requires much more storage or much more processing, then there might be a requirement to up the cores and up the storage and so on. But the software itself is available to all of the key stakeholders within the integrated care system. It enables sharing of code and artifacts. So as a developer within Imperial, I can build an interface between Cerner and some PACS system, make that available in a shared database, and then another developer in Chelsea and Westminster can pick that up and do some modifications that might be relevant to Chelsea and Westminster. And the final point is that it is very easy to trial. I mean, you saw Edward kind of hitting the buttons there, and in order to spin one of these things up and load some code in it and try it, it's something you can do in, certainly you can do in hours. It won't take days, it will take hours for you to be able to do this. So next steps, there's a link over here which is not that observable in this font, but this will be made available to you at the end of this session. This is an e-learning session that looks at an overview of Health Connect Cloud. And finally, if this is something that's of interest to yourselves, please feel free to contact your InterSystems account team, and we'll be more than happy to help you in evaluating this, this new and exciting solution. So that's it for me in terms of what I want to present. And if you have any questions, be more than happy to take them.